Hello students, I am Arunima. Welcome to the first lecture of hydrocarbons. Before starting the chapter, we need to know the meaning of the word hydrocarbons. Hydrocarbons are referred to such compounds which are made up of carbon and hydrogen atoms. They are broadly known as the organic compounds. In organic compounds, there are different classes of compounds like alkanes, alkenes, alkynes, aldehydes, alcohols, etc. So, basically in this chapter of hydrocarbons, we will study about the alkanes, alkenes, alkynes and aromatic hydrocarbons. So, hydrocarbons may contain other heteroatoms also, but the major constituent should be carbon and hydrogen. So, hydrocarbons are mostly of two types, saturated and unsaturated. So, hydrocarbons are of two types, saturated and unsaturated. So, saturated hydrocarbons are those which are made up of carbon-carbon single bonds only. So, in the saturated hydrocarbons, all the bonds will be single bonds between carbon and carbon. But in case of unsaturated hydrocarbons, there has to be CC multiple bonds. It can be double bond, it can be triple bond also. So, when at least one multiple bond is present in a compound, only then we will call it unsaturated. Okay. So, in the saturated hydrocarbons, there can be again two types. One possibility is open chain. Generally, we call them alkanes. Okay. Open chain means like this, there will be no closed loops. It can be straight or branched. And another type is closed chain or rings. That is, there will be some cyclic system like this, a 3-membered ring, or this is a 6-membered ring. So, for such compounds we call them cycloalkanes. Okay. So, these are saturated and unsaturated. So, majorly in this chapter we will read about alkanes which come under the saturated hydrocarbons, and among the unsaturated hydrocarbons we will have alkenes, alkynes and aromatic hydrocarbons. Okay. So, first of all, we need to know a very basic rule of organic chemistry, that is, carbon will have a valency of 4. That is, carbon will form total 4 bonds. In any neutral organic compound or any neutral compound, carbon should have 4 bonds. So, we should fulfill the valency of 4 for making any compound. So, let us start with alkanes. So, we have already discussed that alkanes can be open chain or closed chain. These are also alkanes, but these come under a special category cycloalkanes. The smallest alkane is methane. This is the smallest alkane which has the formula of CH4. That is, carbon will have bonds with 4 hydrogen. Now, if we replace one hydrogen from methane and we replace it with another carbon atom, then what happens? 3 hydrogens are as it is and we replace it with another carbon atom. So, when we have placed another carbon atom, it should also fulfill the valency of 4. So, one bond is with this carbon and there will be 3 more hydrogen. Let us say this is C1 and this is C2. So, C1 has 4 bonds and C2 also has 4 bonds. So, the formula can be written as C2 and 6 hydrogen. So, C2H6. This was methane CH4 and for C2H6 we will call this ethane. Okay. Now, this is the structure of ethane. Now, again if we replace one hydrogen with carbon, that is one CH3 unit, then we get this. 1, 2 and 3. So, this can be written as C3 and H8. So, this is called propane. So, basically by replacing one hydrogen in each step and replacing it with a CH3 unit, we get the bigger alkanes. So, this goes like this. If we form a table now with the number of carbon, molecular formula and names. So, let us start with 1. When the number of carbon is 1, this has the molecular formula CH4. We call this methane. When the number of carbon is 2, it has a molecular formula of C2H6 and we call this ethane. For 3 carbons, C3H8 known as propane. For 4 carbons, C4H10 which is called butane. For 5 carbons, C5H12 called pentane. For 6 carbons, C6H14 hexane. For 7 carbons, C7H16, this is heptane. For 8 carbons, C8H18, this is octane. For C9, C9H20, this is nonane. And for 10, C10H22, this is decane. So, these are the first 10 alkanes. Now, we will see a similarity in the formulas. Let us say if we consider the number of carbons as n. So, when C was 1, for CH4, that is n equal to 1. Then what was the number of hydrogen? It was 4. So, we can write 4 as 2 into 1 plus 2. So, 2n plus 2. Similarly, if we see ethane, that is C2H6, n was equal to 2 and this is 6. 6 can be written as 2 into 2 plus 2, that is 2n plus 2. So, this is the general formula of writing alkanes, CnH2n plus 2. This is considered to be the general formula of alkanes. And when we put some integer in this, then we get the corresponding alkane. For example, if we talk for 8 carbons, then n is equal to 8 and hydrogen will be 2 into 8 is 16 plus 2, that is 18, C8H18. So, indeed C8H18 is the formula for octane, right. So, by using this general formula, we can get the alkanes one by one. So, this is called a homologous series. Homologous series. So, what is the definition of homologous series? Homologous series can be written as a family of organic compounds with similar chemical properties in which members differ from one another by additional CH2 group. Additional CH2 group. So, for each alkane, when we add CH2, then we get the next higher alkane, right. So, if we add CH2 to methane, that is 1 carbon and 2 hydrogens. When we add 1 carbon to methane, we get C2 and 2 hydrogens, 4 plus 2 is 6. So, each alkane differs from its next higher alkane with a CH2. Now, we need to know about the structure. So, the structure of methane is tetrahedral. Okay. So, how does it look? Suppose this is a carbon atom. So, one sp3 orbital of carbon is bonded with one 1s orbital of hydrogen. Okay. So, let us say this is the sp3 orbital, then this is a hydrogen. So, this is the structure of methane. Now, if we join these hydrogen with straight lines, we get a structure like this. This is the shape of a tetrahedron. So, the shape of methane is called tetrahedral. Now, these bond angles, that is HCH, that is the bond angle between two CH bonds. Bond angle between two CH bonds. We can write this as HCH. This is equal to 109.5 degrees. This is the bond angle of methane. Now, for higher alkanes, we can again like replace one hydrogen and then one tetrahedral will form again. So, they can have such structures. So, what about the names? We have discussed these names. These are all straight chain alkanes. Now, if we form some branched chain, say like this, if such branched chains are formed, then what will we call them? So, before discussing about the branched chains, we need to know another thing. That is, we have discussed that the methane, ethane, propane, these are the names of the alkanes. Now, we know that this was the structure of methane, right? By replacing one hydrogen, we had added CH3 group. Right? So, if we have this CH3 unit and we can add any other unit in this place, like we had replaced hydrogen. So, this CH3 unit is known as methyl group. This is not a molecule in itself, it is known as the methyl group. Similarly, now if we remove one hydrogen from here, and let us say we add some other group here. So, now this unit, that is C2H5 or CH3CH2, this unit is known as ethyl group. So, similarly, as we move higher up in the alkane series, we get the corresponding alkyl group. So, as a collective term, they are called alkyl groups. So, you have seen that the alkyl groups have one hydrogen less than the alkanes, right? Methane is CH4, but methyl group is CH3. Similarly, ethane is C2H6, but ethyl group is C2H5. So, alkyl groups have a general formula CnH2n plus 1. Alkanes had CnH2n plus 2. So, alkyl groups will have CnH2n plus 1. So, before starting with the names of alkanes, we will study about isomers. What is isomerism? So, let us talk about isomerism. So, the definition of isomerism is isomerism is the phenomenon in which more than one compounds have the same molecular formula but different structural formula. Okay. So, isomerism is the phenomenon in which more than one compounds have the same molecular formula but different structural formula. Okay. So, in a simple language we can say that isomers have same number of atoms but the arrangements are different. Okay. Same number of atoms of similar elements of course, but the arrangements are different. So, isomerism can have further classifications. Isomerism is broadly classified as structural isomers and stereoisomers. Stereoisomers. Okay. Structural isomers again have subdivisions, chain, positional, functional, metamerism, tautomerism, and ring chain isomers. And stereoisomers have also been further classified as configurational, and conformational. Okay. And within the configurational, again there are geometrical and optical. Within the optical isomerism, it can be of two types, diastereomers and enantiomers. So, first of all, we will study about chain isomers. This is the most basic form of isomerism. The first three alkanes, that is methane, ethane and propane, they do not have any structural isomers. This is to be noted that methane, ethane and propane do not have only structural isomers, they do have stereoisomers. Stereoisomers are possible, like they have different conformations, but they do not have structural isomers. First of all, what is the molecular formula of butane? Butane is C4H10, right? This is butane. Now, maintaining this molecular formula, we can write some different structures. The basic structure is of course this. This is the basic structure of butane. This is known as normal butane or N-butane. Okay. Now, if we write like this and we then add hydrogens. What is the molecular formula of this compound? We have 4 carbons, that is C4, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogens. So, see, the molecular formula is still maintained, but are these two structures same? No, they aren't. These two structures are different. This is known as isobutane. Okay, isobutane or two-methyl propane. Why? Because we know that in IUPAC nomenclature, we count the longest carbon chain as the base chain or the parent chain. So, in the longest carbon chain, there are 3 carbons here, right? Even if we count this like this 1, 2 and 3, then also we will have the longest carbon chain with 3 carbons. So, the parental term will be propane, and in the second position there is one CH3 group, that is one methyl group. So, we call it 2-methyl propane or isobutane. Okay. So, butane has 2 chain isomers. These are chain isomers. Why? Because the difference is in the length of the chain. Difference in chain length. So, we call them chain isomers. Okay. So, butane has 2 chain isomers, N-butane and isobutane. Now, if we look at pentane. Okay. So, what is the formula of pentane? C5H12. So, we can write like this. Okay. CH3, CH2, 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 CH3. We can write like this in the straight chain form. This is known as normal pentane or N-pentane. Okay. Now, if we write in the branched chain form, let's put the hydrogens CH3, CH2, CH. So, another one hydrogen will be there, and this is CH3. If we write like this, then this is a branched chain. This is called isopentane. Now, 1, 2, 3, 4. we can write like this, or 1, 2, 3, 4. Which one is correct? This one is correct, because we always take that name in IUPAC where the substituted group is in the lowest position, that is here it is in the second position. So, we call this as 2-methyl butane. Why butane? Because the parent chain has 4 carbons in it. So, it will be butane, and since in the second position 1-methyl group is present, we call it 2-methyl butane, right. Now, if we suppose we remove the methane from here and which we place here, then also the same thing, because if we number from this side, then it will come in the second position. So, there is no difference. Now, another structure can also be possible. If we write the carbon chain like this, this carbon has 4 bonds fulfilled, so no hydrogen. Okay. Here also what is the formula? C5 and H12, right. This is known as neopentane, or if we write the IUPAC name, then what is the longest carbon chain? 1, 2 and 3, that is it is 3 carbon chain, and 2 methyl groups are there in the second position. So, we can call this as 2,2-dimethyl propane, 2,2-dimethyl propane or neopentane. So, pentane has 3 chain isomers, okay, N-pentane, isopentane and neopentane. Now, till now we have seen only chain isomers, but if we write the isomers of hexane, then we will get another new type of isomer. So, what is the formula of hexane? C6H14, right. So, it can be written as CH3, CH2, 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 CH3. So, this is the basic straight chain, that is N-hexane. Now, what is the second possibility? N-hexane has 6 carbon chain. Now, another structure with 6 carbon chain is not possible. So, we have to try with 5 carbon chain. So, if we write a methyl group here, okay. So, 1, 2, 3, 4, 5. So, this is 5 carbon chain and a methyl at the second position. We call this as 2-methyl pentane. Okay. So, 1 and 2. What will be the next possibility? Now, in case of pentane, if we were moving the methyl group, then also the same structure was there, but in hexane that will not be the case. We can write like this also, okay, 1, 2, 3, 4, 5. So, now this becomes 3-methyl pentane. Both of these have 5 carbon chain. Okay. Now, another molecule with 5 carbon chain is not possible, because again if we change the position, this will become number 2 only. So, now we can have 4 carbon chain. So, four carbon chain. Okay. Now, we have 2 methyl groups then. So, we can put one here and one here. So, this is another structure 1, 2, 3, 4. So, this becomes 2, 2 dimethyl butane. Okay. 2,3 dimethyl butane, because one methyl is at the second position, one methyl is at the third position. So, we call this 2,3 dimethyl butane. Now, similarly, another structure will be possible with 4 carbon chain. If we place the methyl group in the same carbon, okay, then what we will call this 1, 2, 3, 4. This is 2,2 dimethyl butane. Okay. Now, if we put the 2 methyl groups in this, then also it will remain 2,2 dimethyl butane. So, these two have 4 carbon chains. So, hexane has 5 structural isomers. One has 6 carbon chain, one has 5 carbon chain, 2 has 5 carbon chains and 2 have 4 carbon chains. So, we can say that 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. According to the chain length, so also 2, 4, 2, 5, 3, 4, 3, 5, all of these are chain isomers. Because the difference in these two compounds in each case is in the length of the chain. So, these are chain isomers, we know that. Now, if we look at 2 and 3, see in 2 the position of this substituted methyl group was at the second carbon, but in 3 the position of the methyl group is in the third carbon. The chain length is same, both have 5 carbon chains, but the difference is in the position of the methyl group. So, these are called positional isomers. So, 2 and 3 are positional isomers, also for 4 and 5. In 4 and 5, position of one methyl group is same, but the other methyl group, in 4 it was in the third position, in 5 it is in the second position. So, 4 and 5 are also positional isomers. So, what are positional isomers? Positional isomers are the isomers where difference is in the position of the substituted groups. The substituted groups will not be different. The substituted groups will be same, just the position will be different. So, these are called positional isomers. Now, in writing all these isomers, we have seen that, for example, this carbon, this carbon is bonded to only one carbon and 3 hydrogen. Now for example, this carbon is bonded to 2 carbons and 2 hydrogen. This one is bonded to 3 carbons and 1 hydrogen, and for this one, this carbon is bonded to 4 carbons and no hydrogen is there. So according to the bonded number of carbons, we can also divide them in primary, secondary, tertiary and quaternary. So let us say primary. Which is written as 1 degree. So primary carbon atom is a carbon atom which is bonded to zero or 1 carbon. Okay, 0 or 1 carbon. So for example, the methyl carbon is not bonded to any other carbon. So this is also primary. And for ethane also, both these carbons are bonded to only one other carbon and 3 other hydrogen. So these are 1 degree or primary. Now the second one is secondary, which is written as 2 degree. That is a carbon atom bonded to 2 other carbon atoms. Okay. When a carbon atom is bonded to 2 other carbon atoms, that is called secondary. Let us say for propane. For propane, these two are primary, but this carbon, see, this carbon is bonded to 2 more carbon atoms and other 2 are with hydrogens. So this carbon is secondary or 2 degree. The third one is tertiary or 3 degree. That is a carbon atom bonded to 3 other carbon atoms. Okay. So let us say for isobutane, right. These 3 are primary, but for this carbon it is bonded to 1, 2 and 3 other carbon atoms and another one is hydrogen. So this is called tertiary or 3 degree. Now the last one is quaternary. Or 4 degree. That is a carbon atom bonded to 4 other carbon atoms. Okay. So let us say this was the case of isobutane, right? Yes. So let us consider neopentane. For neopentane, all these carbons were primary, but for this carbon it is bonded with 1, 2, 3 and 4. 4 carbon atoms. There is no hydrogen atom attached to this. So, this is called quaternary or 4 degree. So, let us say this is a molecule . This is the molecule, okay. So, where are the primary carbons? 1 degree, this is 1 degree, this is primary, these two are also primary. So, we can see that all the primary carbons are in the terminals. So, of course, they have to be in the terminals because there are no carbon on the other side. So, terminal carbons are always primary. What are the secondary carbon atoms here? Which one is secondary? This one is secondary because this is bonded to 2 carbon atoms. And what is tertiary? This carbon is tertiary because it is bonded to 3 carbons, right. So, this is tertiary and this carbon is quaternary because it is bonded to 4 other carbon atoms. So, now we have seen about the alkanes, the name of the alkanes, homologous series, general formula, and we have also discussed about some basic isomerism. So, now we need to practice some IUPAC nomenclature for some better understanding. So, let us see some examples. Okay. So, let us see the first one. So, this is the compound, okay. So, we have to count the longest carbon chain. So, let us start from here 1, 2, 3, 4, 5, 6. Why will we count from this side and not this side? Because from this side if we count, then the first substitution is coming in the third position, but from here the substitution is coming in the second position. So, we will name it as, now among methyl and ethyl groups, E comes alphabetically before M. So, ethyl will be first. So, we will write 4 ethyl, 2 methyl and 6 carbons. So, hexane. Okay. If we had numbered from this carbon and we have taken this as substitution, then also the same thing would have happened. So, let us see a second example. So, this is a big compound. Okay. So, now let us start nomenclature. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if we count from this side, then 1, 2, 3, 4, 5, 6, 7, 8, 9. So, in both the cases, the substitution is the fifth position. So, we can count from any side. Now, in this group what happens? If we try to name this group separately, then there are 1, 2, 3 carbons. 3 carbons in the main chain and 2 methyl groups are here in the second position. So, we will name it like this. First 5, since the group is in the fifth position, then we will put a bracket. Now, we will name the group 2,2 dimethyl, 2,2 dimethyl. Now, what is the whole group? Propyl, right? 1, 2, 3, 3 carbon chain. So, 2,2 dimethyl, it should be 2,2 dimethyl propane, but this is not propane, this is propyl group, since it is attached to another compound, right. So, 2,2 dimethyl propyl, and what is 9 carbon chain called? It is called nonane. So, 5,2,2 dimethyl propyl nonane. This is the name of the compound. Let us see another example. Okay. Let us start numbering 1, 2, 3, 4, 5, 6, 7, 8. If we start from this side, 1, 2, 3, 4, 5, 6, 7, 8. So, in this case, the first substitution comes at the third position. So, we will count from this side. So, and what is these groups? These groups are ethyl groups, and this group, this is basically 1, 2, 3, right? 3 carbons are there. This is a propyl group, but the other compound that is attached to the propyl group is not attached in the first carbon, right. If this was like this, then we would call this as propyl group. But since in this case the attachment is with the second carbon of the propyl chain, so we call this isopropyl. Okay. So, the name of this compound will be 3,3 diethyl 5 isopropyl 4 methyl, right? Methyl is in the 4 position. 4 methyl. Now, we will write the groups in the form of alphabetical order. E comes first, so diethyl will be first, then I, so isopropyl, after that M, so then it will be methyl, and 8 carbon chain, so octane. So, 3,3-diethyl, 5-isopropyl, 4-methyl octane. Now, we have practiced from structure to nomenclature. Now, we can also practice nomenclature to structure. So, let us say 3, 4, 4, 5, tetramethyl heptane. This is the name. So, how will we write it? First, the parent chain is heptane. So, we will have to write 7 carbons. One, 2, 3, 4, 5, 6, 7. Okay. 3, 4, 4, 5. So, one is at 3, 2 at 4 and 1 at 5. What are the substitutions? Tetramethyl. So, 4 of these substitutions are methyl. So, we will put methyl here. Okay. Now, we will fill up the hydrogens. CH3, CH2, CH. This is a quaternary carbon. So, there will be no hydrogen. CH, CH2, CH3. So, this is the structure of this compound 3,4,4,5 tetramethyl heptane. And another one is 2,5-dimethyl hexane. So, since we have hexane, we will write 6 carbons. 1, 2, 3, 4, 5, 6, and 2 groups are in the 2 and 5. Dimethyl. So, both of these are methyl groups. Now, we will put hydrogens. CH3, CH, CH2, CH2, CH, CH3. This is 2,5-dimethyl hexane. So, in this lecture, we have discussed about the basic concepts about alkanes. We have studied about the structural isomers of alkanes and the naming of the alkanes. Now, in the next class, we will study about the conformational isomers of smaller alkanes and we will go on with the preparation of alkanes. Thank you.